Have you ever stared up at the night sky and wondered what came before everything? Before the stars? Before the galaxies? Before space itself? Well, you're about to embark on a mind-bending journey that will challenge everything you thought you knew about reality. Drop a comment below and let me know where you're watching from and what time it is right now. Because we're about to explore the most profound mystery in all of existence. What if I told you that the question, what was there before the Big Bang, might be the wrong question entirely? What if time itself didn't exist before that moment? What if asking what came before the Big Bang is like asking what's north of the North Pole? Your brain is probably already starting to hurt, and we haven't even gotten to the really crazy stuff yet. Right now, as you're watching this video, you're sitting in a universe that's expanding at an incredible rate. Every second, space itself is stretching, carrying galaxies away from each other at speeds that would make your head spin. But here's where it gets absolutely wild. If we could somehow reverse this expansion, like rewinding a cosmic movie, we'd see everything in the universe getting closer and closer together until we reach a point about 13.8 billion years ago, when everything we know was compressed into a space smaller than the period at the end of this sentence. But what happened before that moment? This question has kept scientists awake at night for decades, and the answers they've come up with are so bizarre that they sound like science fiction. Some of the world's brightest minds have proposed ideas that would make even the most imaginative storyteller's jaw drop. We're talking about concepts that challenge the very nature of reality itself. Imagine for a moment that you could travel back in time. You'd see the universe getting smaller and smaller, hotter and hotter, until you reach that critical moment 13.8 billion years ago. At that point, all the matter and energy in the entire universe was packed into a space so incredibly tiny that our current understanding of physics completely breaks down. The temperatures were so extreme that atoms couldn't even exist. The density was so intense that a teaspoon of this primordial soup would weigh more than all the mountains on Earth combined. But here's the thing that will absolutely blow your mind. Many scientists now believe that asking what came before the Big Bang is like asking what color is the number 7. The question itself might not make sense because time, as we understand it, might have been created along with space during the Big Bang. This means that the concept of before might not have any meaning in this context. Think about it this way. If time itself began with the Big Bang, then there was no before to speak of. It's like trying to find the beginning of a circle. You can trace your finger around it forever, but you'll never find a starting point. This concept is so mind-bending that even Einstein struggled with it. And he was the guy who figured out that time and space are connected in ways that seem impossible. But wait, it gets even more incredible. Some of today's most brilliant physicists have proposed that our entire universe might be just one bubble in an infinite ocean of bubbles, each one a separate universe with its own laws of physics. This idea, called the multiverse theory, suggests that Big Bangs might be happening all the time, creating new universes constantly. If this is true, then our universe isn't unique. It's just one of countless others, each with its own story of creation. Picture this cosmic foam, where universes are constantly being born and dying, like bubbles in a glass of champagne. Some of these universes might be similar to ours, with stars and planets and maybe even life. Others might be so different that they operate under completely alien laws of physics. In some of these universes, gravity might push instead of pull. In others, time might flow backward. The possibilities are literally infinite. And here's something that will make your head spin even more. Some scientists think that our universe might be stuck in an endless cycle of expansion and contraction. This means that before our Big Bang, there might have been another universe that collapsed in on itself, creating the conditions for our universe to be born. And when our universe eventually dies, it might collapse and give birth to yet another universe. It's like a cosmic heartbeat that's been going on forever and will continue forever. But the really mind-blowing part is that we might never be able to prove what came before the Big Bang. The very act of the Big Bang might have erased all evidence of what came before it. It's like trying to figure out what a building looked like before it was demolished, but the demolition was so complete that it vaporized every single brick, every piece of wood, every nail. The Big Bang might have been the ultimate cosmic reset button. However, some scientists aren't giving up that easily. They're looking for clues in the cosmic microwave background radiation, which is like the afterglow of the Big Bang that's still visible today. This radiation carries information about the very first moments of our universe, and some researchers think they might be able to find hints about what came before. It's like trying to solve a mystery by examining the smoke after a fire has burned out. One of the most fascinating theories suggests that our universe might have been born from a quantum fluctuation in a pre-existing space. This means that our entire reality, with all its galaxies and stars and planets, might have popped into existence from literally nothing, like a cosmic magic trick. The quantum world is already weird enough, with particles that can exist in multiple places at once, and effects that happen before their causes. But this idea takes weirdness to a whole new level. Imagine that empty space isn't really empty at all, but is actually bubbling with activity on the smallest possible scales. Virtual particles are constantly popping in and out of existence, appearing from nowhere and disappearing back into nothing. Most of these fluctuations are tiny and cancel each other out. But what if, just once, a fluctuation was so large that it created an entire universe? What if that's exactly what happened 13.8 billion years ago? This idea is so strange that it seems impossible. But quantum mechanics has already shown us that impossible things happen all the time on the smallest scales. Particles can tunnel through walls, exist in multiple places simultaneously, and be connected across vast distances in ways that Einstein called spooky action at a distance. If these bizarre quantum effects can happen on small scales, why not on cosmic scales? Some scientists have even proposed that our universe might be a hologram projected from a two-dimensional surface. This holographic principle suggests that all the information in our three-dimensional universe is actually encoded on a distant two-dimensional boundary. It's like saying that everything you see around you, including yourself, is just a projection from a cosmic movie screen that exists at the edge of the universe. The implications of this are staggering. If our universe is indeed a hologram, then what we think of as solid matter might be nothing more than information patterns dancing on a distant surface. Your body, your thoughts, your memories, everything that makes you who you are, might be just information encoded in a cosmic database. And if that's true, then the question of what came before the Big Bang becomes even more mysterious, because we'd need to understand what created the cosmic projection system in the first place. But here's where things get really wild. Some physicists have suggested that consciousness itself might play a role in the creation of reality. This idea, which sounds like something out of a science fiction movie, proposes that the act of observation might actually create the universe we observe. It's called the participatory universe theory, and it suggests that we're not just passive observers of reality, we're actually helping to create it by the very act of looking at it. If this theory is correct, then the question of what came before the Big Bang becomes even more profound. It might not just be about physics and mathematics. It might be about consciousness and observation. The universe might have needed conscious observers to bring it into existence, which creates a mind-bending paradox. How can conscious beings create a universe that they need to exist in first? This brings us to one of the most controversial ideas in modern physics, the anthropic principle. This concept suggests that the universe has exactly the right properties to support life, because if it didn't, we wouldn't be here to observe it. In other words, we exist in a universe that's perfectly suited for our existence, because universes that aren't suited for life don't have anyone around to notice them. But if the anthropic principle is true, it raises incredible questions about what came before the Big Bang. Were there countless other Big Bangs that created universes unsuitable for life? Are we living in the one universe out of billions or trillions that happen to get the cosmic lottery numbers just right? The odds of our universe having exactly the right properties for life are so astronomically small that it seems impossible unless there were countless other attempts. Some scientists have calculated that if you changed any of the fundamental constants of physics by even the tiniest amount, our universe would be completely different. If gravity were slightly stronger, stars would burn out too quickly for life to evolve. If it were slightly weaker, stars wouldn't form at all. If the electromagnetic force were different, atoms wouldn't hold together. The fact that everything is so perfectly balanced seems to suggest that either we're incredibly lucky, or there's something we don't understand about the nature of reality itself. This is where the simulation hypothesis enters the picture. Some physicists and philosophers have seriously proposed that our entire universe might be a computer simulation running on some unimaginably advanced system. If this is true, then what came before the Big Bang might simply be the moment when someone or something pressed the start button on the cosmic computer program. The simulation hypothesis might sound like science fiction, but it's based on some compelling logic. If it's possible for a civilization to create realistic simulations of universes, and if such civilizations are likely to create many simulations, then statistically speaking, we're more likely to be living in a simulation than in the original reality. It's like saying that there are more copies of a movie than there are original films, so if you randomly pick a movie to watch, you're more likely to get a copy. But even if we are living in a simulation, it doesn't really answer the question of what came before the Big Bang. It just moves the question up one level. What came before the civilization that created our simulation? What came before their Big Bang? We might be facing an infinite regress, where every answer just leads to another question. And that's not even the strangest possibility. Some theories suggest that cause and effect might work differently on cosmic scales. What if the Big Bang wasn't caused by something that came before it, but by something that came after it? What if the future somehow reached back and caused the past to exist? This idea, called retrocausality, suggests that the arrow of time might not be as straightforward as we think. In quantum mechanics, we already see hints that the future can influence the past. Certain experiments suggest that measuring a particle in the present can retroactively determine its state in the past. If this principle applies on cosmic scales, then the question of what came before the Big Bang might be answered by looking at what comes after it. Maybe the universe created itself through some cosmic bootstrap paradox, where the effect becomes its own cause. These ideas challenge our most basic assumptions about reality. We assume that causes come before effects, that time flows in one direction, that something can't come from nothing. But the deeper we dig into the mystery of what came before the Big Bang, the more we realize that these assumptions might be wrong. The universe might operate according to rules that are so alien to our everyday experience that we can barely comprehend them. As we continue to explore these mind-bending possibilities, one thing becomes clear. The question of what came before the Big Bang is far from settled. Every answer we discover seems to reveal 10 new questions. Every theory we develop opens up new mysteries. And every experiment we conduct shows us that the universe is stranger and more wonderful than we ever imagined. What's even more incredible is that we're living in a time when we might actually be able to find answers to these questions. Advanced telescopes are peering deeper into space and further back in time than ever before. Particle accelerators are recreating conditions that existed just moments after the Big Bang. Computer simulations are modeling cosmic evolution with unprecedented accuracy. We might be on the verge of the greatest discovery in human history, the answer to what came before everything. But regardless of what we discover, one thing is certain. The journey to find these answers is changing our understanding of reality itself. We're not just exploring the origins of the universe. We're exploring the nature of existence, consciousness, and our place in the cosmic story. And that journey is just beginning. So, where do we even begin this cosmic bedtime story? Let's go back to that moment. That impossible, tiny point where everything we know was born. It's a moment that our minds can't really wrap around, but let's try. Imagine all the light, all the matter, all the energy of every star, every planet, every galaxy, all squeezed into a space smaller than a single grain of sand. The rulebook of our universe, the laws of physics that we rely on every day, simply didn't apply. It was a realm of pure, raw potential. A state so alien that words like hot and dense don't even begin to do it justice. It's in this place, this primordial furnace, that our story starts. But the most mind-bending part isn't what was in it, but the idea that it might be the only when there ever was. The idea that time itself popped into existence with the Big Bang is one of the most profound concepts in all of science. It's a favorite idea of many physicists, including the legendary Stephen Hawking. He helped to develop a concept that paints the universe as having no boundary, no starting line. Imagine you're a tiny ant walking on the surface of a perfectly smooth sphere. You can walk forever in any direction, but you will never find an edge. You'll never find a start to the sphere. Hawking suggested that our universe's timeline might be like that. If you travel back in time, as you get closer to the Big Bang, time itself begins to curve and blend with space, until the very idea of before just dissolves into meaninglessness. There's no edge to fall off, no wall to crash into, just a smooth, continuous beginning where time as a separate, forward-marching concept ceases to be. It wasn't that there was nothing before the Big Bang, it's that there was no before. It's a tricky thought, isn't it? Let me know in the comments if this idea of a beginningless beginning makes your brain tingle. But what if that's not the whole story? What if our universe is not a solo act, but part of an eternal cosmic cycle? This brings us to the beautiful and poetic idea of the Big Bounce. Imagine the universe as a lung, breathing in and out over timescales so vast they make 13.8 billion years look like the blink of an eye. In this story, our Big Bang wasn't the absolute beginning, but rather the moment of exhale. Before our universe expanded, there was another universe, perhaps very much like our own, that had lived its life, expanded to its fullest, and then, under the relentless pull of its own gravity, began to contract. It fell back in on itself, not in a chaotic crash, but in a cosmic inhale, getting smaller and hotter and denser until it reached a point of maximum compression. And then, it bounced. It rebounded. And all that energy and matter from a previous cosmos was repurposed, reborn into the universe we now call home. Our Big Bang was the big bounce that started the next cycle. This means that our universe could be made from the recycled stardust of a parent universe. Everything you see, the atoms in your body, the light from distant stars, might have existed in a different form in a cosmos that came before. And in the far, far distant future, when our universe has expanded and cooled and all the stars have died out, perhaps it too will begin to contract, setting the stage for the next Big Bang, the next cosmic generation. It's an endless, pulsating rhythm of creation and recreation. If our universe was born from the ashes of a previous one, what do you imagine that older universe might have been like? Was it filled with wonders we can't even dream of? Share your most imaginative thoughts below. This endless cycle removes the need for a singular beginning. The universe, in this view, has always existed and will always exist, forever bouncing between expansion and contraction. It's a comforting thought in a way, isn't it? A universe that never truly dies, but is eternally reborn. Now, let's venture into an even stranger realm. A place where our universe isn't the only one in existence. This is the idea of the multiverse, and it's one of the most popular and mind-expanding theories out there. The theory that drives this idea is called eternal inflation. Imagine the moment after the Big Bang, when the universe was expanding at an unimaginable rate. The idea is that this expansion, this inflation, is not something that happened just once. It's the default state of reality. It's a cosmic ocean of inflating space that is always churning, always expanding, and it never ever stops. But within this eternally inflating ocean, little pockets can stop inflating and cool down. Each of these pockets becomes a bubble universe, with its own Big Bang, its own laws of physics, its own destiny. Our universe would be just one of these bubbles, a tiny island of calm in an infinite, chaotic sea of eternal expansion. And new bubbles, new universes, are being created all the time. Think of it like a pot of boiling water. Our universe is just one bubble that has risen to the surface, but right next to it, countless other bubbles are forming, growing, and popping into existence. This means there could be an infinite number of other universes out there, each one completely separate and inaccessible to us. Some might be almost identical to ours, with tiny, subtle differences. Maybe in one of them you decided to wear a different shirt today. In another, dinosaurs never went extinct. But other universes could be wildly different, governed by laws of physics so alien that we couldn't even begin to comprehend them. Universes with 2 dimensions of time instead of 1. Universes where gravity is a repulsive force, pushing things apart instead of pulling them together. Universes made of particles we've never dreamed of. The sheer scale of this idea is almost too much to handle. An infinite number of universes, an infinite number of possibilities playing out all at once. If this is true, then the question, what was there before the Big Bang, changes. Before our Big Bang, there was simply the multiverse. There was the inflating cosmic ocean from which our bubble universe happened to emerge. Our beginning was just one event in a much larger, eternal reality. The multiverse theory suggests that anything that can happen will happen in some corner of this vast cosmic landscape. It's a humbling thought. It means our entire existence, everything we've ever known or will know, is just a single grain of sand on an infinite beach. It makes you feel small, but also part of something unimaginably grand. But there's another story, one that comes from one of the most ambitious theories in all of physics, string theory. String theory tries to be the theory of everything, a single framework that can explain all the forces and particles of nature. In the world of string theory, the fundamental building blocks of reality aren't point-like particles, but tiny, vibrating, one-dimensional strings of energy. Everything we see, from an electron to a quark, is just a different vibration, a different musical note played on these fundamental cosmic strings. And string theory doesn't just describe our familiar 3 dimensions of space and 1 of time. It requires at least 10 dimensions to work mathematically. Most of these extra dimensions are thought to be curled up, too small for us to ever see, but they are there, woven into the fabric of reality. Within this higher dimensional reality, string theory offers a dramatic and beautiful alternative to the Big Bang singularity. It's called the ekpyrotic model. The name comes from a Greek word meaning conflagration, or fiery destruction and recreation. This model imagines our universe as existing on a 3-dimensional brane, short for membrane. Think of it as a vast, flat sheet floating in a higher dimensional space. Now, imagine another brane, another universe, floating parallel to ours in this same higher dimensional void. For eons, these two brain worlds might drift through this larger space, like two giant cosmic tapestries in the wind, completely unaware of each other's existence. But what if their paths were destined to cross? In this story, the Big Bang wasn't a beginning from an infinitely dense point. Instead, it was the result of these two brains colliding. It wouldn't be a violent, destructive crash, but a gentle, yet cataclysmically energetic touch. As the two brains came together, the kinetic energy of their collision would be transformed into the matter and radiation that filled our fledgling universe. The collision itself would be the bang, igniting our universe and setting off its expansion. After the collision, the brains would pull apart again, and our universe would be left to cool, form galaxies, stars, and eventually, us. And the cycle could repeat. The brains could drift apart, then eventually be drawn back together by some force, leading to another collision, another Big Bang, another universe. What's so appealing about this idea is that it avoids the problematic singularity. The universe doesn't have to start from an impossible point of infinite density. Instead, it starts from a collision in a higher dimension. The universe before the bang wasn't a point. It was another brain, another universe, with its own space and time. It provides a before that is physical and describable, even if it exists in dimensions we can't perceive. It's a vision of cosmic creation as a grand, slow ballet between worlds, a gentle but powerful clash that gives birth to reality as we know it. It's a story that feels both epic and strangely serene. Which of these origin stories resonates with you the most so far? The lonely, no boundary beginning, the eternal cosmic breath of the Big Bounce, the infinite bubbling sea of the multiverse, or the cosmic ballet of colliding brains? Let me know in the comments. These theories are pushing the boundaries of what we can even imagine, taking us on a journey far beyond the familiar shores of our everyday experience. They paint a picture of a cosmos that is far more complex, more mysterious, and more magical than our ancestors could have ever dreamed. We are living in a golden age of cosmology, where we have the tools and the theories to seriously ask these ultimate questions. But with every layer we peel back, we find new layers of mystery underneath. The universe is a grand puzzle, and we've only just begun to piece together the edges. We are like children, on the shore of a vast cosmic ocean, picking up a few shiny pebbles of knowledge here and there, while the great ocean of truth lies undiscovered before us. And the biggest question of all, what lies on the other side of that ocean? What came before the beginning of our world? Remains the most tantalizing mystery of all. The search for this answer is not just a scientific quest, it's a deeply human one. It's about understanding our own origins, our place in the grand scheme of things, and the ultimate nature of reality itself. And the journey is far from over. Think for a moment about the evidence. How could we possibly know if any of these incredible stories are true? The Big Bang itself was like a cosmic furnace, an event so extreme that it should have wiped clean the slate of any information that came before it. It's like a book that starts on page 1, with no introduction, no preface, no mention of the author or what inspired them. So how can we hope to read the pages that were never written? The answer might be hidden in the most ancient light in the universe. It's called the Cosmic Microwave Background, or CMB for short. This faint, gentle glow of radiation fills the entire sky, and it's essentially the afterglow of the Big Bang itself. It's a snapshot of the universe when it was just a baby, only about 0 years old. Before that time, the universe was so hot and dense that it was an opaque fog. Light couldn't travel freely. The CMB is the light from the exact moment that fog finally cleared. Scientists have created incredibly detailed maps of this ancient light, and these maps show tiny, minuscule variations in temperature. These tiny ripples are the seeds from which all the magnificent structures in our universe, like galaxies and galaxy clusters, eventually grew. They are the fossilized echoes of the very first moments of creation. And some physicists believe that within the intricate patterns of these ripples, there might be hidden clues about what came before. It's an audacious idea. It's like trying to reconstruct the shape of a bell by studying the sound waves it produced billions of years ago. For example, if our universe was born from the collision of two brains, some models predict that this would leave a specific subtle signature in the patterns of the CMB. If the universe went through a cycle of bounces, there might be faint traces of the previous cosmos left behind. Scientists are scouring the data from telescopes like the Planck satellite, looking for these telltale signs. They are looking for specific types of patterns, certain kinds of non-randomness that could not be explained by the standard Big Bang model alone. It's a search for a message in a bottle, tossed into the cosmic ocean 13.8 billion years ago. So far, we haven't found a definitive smoking gun. The CMB patterns seem to align very well with the standard model of a single Big Bang from a singularity. But the search is not over. Our instruments are getting more and more sensitive, and our theoretical models are becoming more refined. There's a chance, however small, that one day we might find a bruise on our universe, a faint scar in the fabric of space-time that points to a pre-Big Bang history. Another place we might look for clues is in the behavior of gravity. Gravity is the master architect of the cosmos, shaping the dance of planets, stars, and galaxies, but it's also strangely weak compared to the other fundamental forces of nature. And we still don't have a complete theory of gravity that works at the quantum level, the smallest scales of reality. A theory of quantum gravity is the holy grail of modern physics. It would unite Einstein's theory of general relativity, which describes gravity on a large scale, with quantum mechanics, which describes the bizarre world of subatomic particles. If we had such a theory, we could finally plug it into our equations and run the clock all the way back to the Big Bang itself, and perhaps even beyond. Theories like string theory and another one called loop quantum gravity are attempts to build this bridge. Loop quantum gravity, for instance, paints a very different picture of space-time. It suggests that space itself is not smooth and continuous, but is made up of tiny, indivisible quantum loops, woven together like the threads of a fabric. It's a quantum foam of space-time atoms. In this picture, you can't squeeze space down to an infinitely small point. There's a minimum possible size, a fundamental limit. So, if you rewind the clock on the universe, it doesn't collapse to a singularity. Instead, it reaches this maximum density, this point where the space-time fabric can't be compressed any further, and then it bounces back. Loop quantum gravity naturally predicts a big bounce. It suggests that the singularity of the standard Big Bang model is just a sign that our current theories are incomplete. It's like a mathematical error message telling us that we need a better theory to understand what was really happening. Finding evidence for these quantum gravity effects is incredibly difficult, but some scientists think it might be possible to find imprints of this bounce in the CMB, or in gravitational waves, which are ripples in space-time itself. Gravitational waves are a new and exciting way for us to listen to the universe. They are created by the most violent and energetic events in the cosmos, like the collision of black holes or neutron stars. We've only just started detecting them, but they offer a completely new sense with which to explore the universe. Light can be blocked and absorbed, but gravitational waves travel through almost anything unimpeded. This means they could carry information directly from the heart of the Big Bang itself, from an era that is completely hidden from our telescopes. Some of these pre-Big Bang models, like the colliding brains or a chaotic inflationary period before our own, might have produced a unique background of gravitational waves. If we could build detectors sensitive enough to pick up this primordial gravitational wave hum, it would be like hearing the sound of creation itself. It would be the most profound discovery in the history of science, a direct window into the moment our universe was born, and perhaps a glimpse of what came before. It's a long shot, but the possibility is too tantalizing to ignore. The universe is whispering its secrets to us in these faint gravitational echoes, and we are just now learning how to listen. This quest to find physical proof, a fingerprint of a time before time, is one of the grandest adventures in science. But as we stand now, the evidence is elusive, like trying to see footprints in a storm. This lack of a clear, physical answer doesn't stop us, though. Instead, it pushes us into even more wondrous and stranger territories. It forces us to rely on the power of pure thought, on the elegant beauty of mathematics, and on the untamed wilderness of our imagination. If the clues are not written in the sky, perhaps they are written in the very code of reality itself. This is where our story takes a turn, from the cosmos to the very nature of what it means to be real. Let's revisit an idea so strange it sounds like pure fantasy, but one that is grounded in some of our deepest understanding of physics. This is the holographic principle. We touched on it before, the idea that our three-dimensional universe is a projection from a two-dimensional surface. But let's really try to feel what that means. Imagine your entire life, every sight, every sound, every feeling, is like a magnificent, sprawling movie. You believe you are in a 3D theater, with depth and substance. But the holographic principle suggests that you, the theater, and the entire movie are actually being projected from a single flat film reel at the edge of the cosmos. All the information that makes up you, the chair you're sitting on, The Earth, the Sun, and the most distant galaxy is entirely encoded on this distant, lower-dimensional boundary. This mind-shattering idea didn't come out of nowhere. It emerged from the study of the most mysterious objects in the universe: black holes. When something falls into a black hole, it crosses the event horizon, the point of no return. For a long time, physicists were puzzled by what happens to the information of the thing that falls in. One of the fundamental rules of the universe is that information can never be truly destroyed. So where does it go? The surprising answer that emerged was that the information doesn't get lost in the infinitely dense singularity at the center. Instead, it gets smeared out and stored on the two-dimensional surface of the event horizon itself. It's as if everything that has ever been swallowed by the black hole leaves a permanent imprint on its skin. A star, a planet, a spaceship, their entire essence is encoded on this boundary surface. This led scientists like Gerard Hooft and Leonard Susskind to wonder, if a black hole can store 3D information on its 2D surface, could the entire universe be doing the same thing? Could the boundary of our observable universe, the cosmic horizon, be the hard drive that contains all the data for our reality? If this is true, then we are the hologram. Our perception of 3 dimensions, of solid objects and empty space, might be a grand illusion, a clever projection from a reality that is fundamentally flat. What does this do to our question about the time before the Big Bang? It transforms it completely. Instead of asking what happened in our 3D space before it started expanding, we now have to ask, what was happening on the 2D surface that projects our universe? Did that surface have a beginning? Does time even work the same way there? The creation event might not have been a Big Bang in a 3D space, but perhaps a change in the information pattern on the 2D boundary, like a cosmic artist erasing one picture and starting a new one. The before might be a story written in a language of 2 dimensions, a story we are only just beginning to learn how to read. From one fantastical idea, we slide into another that feels even closer to science fiction, yet is debated seriously by brilliant minds. This is the simulation hypothesis. The core logic is deceptively simple and powerful. Think about the progress of our own technology, especially video games and virtual reality. In just a few decades, we've gone from simple pixelated characters to creating virtual worlds that are becoming increasingly difficult to distinguish from reality. Now, project that progress forward 1,000 years, 1,000,000 years, 1,000,000,000 years. Is it not plausible that a civilization far more advanced than ours would be able to create a simulation of a universe, complete with conscious beings like us who believe their world is real? They could create what are called ancestor simulations, recreating their own past to study it. If it is possible to create such simulations, then an advanced civilization would likely create not just one, but billions of them, for science, for entertainment, for reasons we can't even guess. They would be as easy to spin up as opening a new program on a computer. Now, here's the statistical twist. If there are billions upon billions of simulated universes and only one base reality, which one are you more likely to be in? The odds would overwhelmingly suggest that we are in one of the simulations. We are more likely to be a simulated consciousness living in a simulated universe than we are to be living in the original prime reality. It's a dizzying thought. The world around you, your memories, your feelings, your hopes, and your dreams could be lines of code running on some unimaginably powerful cosmic computer. Could we ever find out? Could we peek behind the curtain and see the code? Some have suggested looking for glitches in the matrix. Perhaps reality isn't perfectly smooth. If it's a simulation, it might have a finite resolution, like the pixels on a screen. If you zoom in far enough, you might see that space and time are not continuous, but are made of tiny, discrete units. Interestingly, some observations in physics hint at this. There appears to be an upper energy limit for cosmic rays, the highest energy particles that travel through space. They never seem to exceed a certain energy, no matter how powerful their source. Some have playfully suggested this could be a processing limit of the simulation, the maximum value the universe's CPU can handle. Of course, there are other, more conventional physical explanations, but it's a fun thought. If we are living in a simulation, the question of what came before the Big Bang gets a very simple, yet profound answer. The Big Bang was the moment the simulation was booted up. It was when someone, or something, typed "run program," and our universe blinked into existence. Before that, maybe the computer was idle. Maybe it was running a different simulation of a completely different universe. Maybe the hardware itself was being built. The ultimate origin question isn't about a cosmic event, but about our creators. Who are the simulators? Are they future humans who became godlike beings? Are they an ancient alien civilization? Are they a form of pure artificial intelligence that evolved beyond biological life? What do you think? If we are in a simulation, who is at the keyboard? Leave your theories in the comments. It's a question that takes us from the realm of physics and cosmology into philosophy and even theology. The origin of our universe might not be found in a telescope, but in understanding the motives of its programmer. This leads us to the most intimate and perhaps most magical possibility of all. We've talked about the universe being a hologram, a simulation, a bubble, a bounce. But what if the secret ingredient, the one thing we've overlooked, is ourselves? What if consciousness is not just a random accident in a dead universe, but a fundamental and necessary component for its existence? This is the core of the participatory anthropic principle, an idea championed by the brilliant physicist John Archibald Wheeler. It takes the weirdness of quantum mechanics and applies it to the entire cosmos. At the quantum level, particles exist in a ghostly state of all possibilities at once, a superposition, until they are measured or observed. The act of observation seems to force a particle to choose a single state to become real. An electron isn't really in any one place until we look for it. Wheeler took this idea to its ultimate conclusion. What if the entire universe, in its earliest moments, existed as a vast, undefined cloud of quantum possibilities, a sea of potential universes, all existing simultaneously in a state of superposition? What then could act as the observer to collapse this cosmic superposition into the single concrete reality we experience? The answer, he proposed, is us. Not us as we were back then, of course, but us now. He suggested that through our acts of observation, from the simple act of looking at the sky to our most advanced telescopic measurements, we are reaching back in time and giving reality to the universe's past. Our observations of the ancient light from the Big Bang are what make the Big Bang real in the way that it was. It's an idea that creates a breathtaking time loop. The universe evolves over billions of years to create conscious observers. Then, those conscious observers look back, and through their act of looking, provide the very reality that allowed them to exist in the first place. It's a self-creating cosmos, a universe that pulls itself up by its own bootstraps. The universe, in this view, is a grand act of self-portraiture. It brought forth beings capable of witnessing its own beauty. And in that act of witnessing, its beauty became real. We are not separate from the universe. Looking in from the outside, we are the universe, looking at itself. We are the universe's way of knowing itself. This completely reframes our place in the cosmos. We are not insignificant specks of dust in a vast, uncaring void. We are necessary participants. Our consciousness is the linchpin that holds the whole structure together. It means that the question of what came before the Big Bang becomes tangled with the question of the origin of consciousness. There was no before in the traditional sense, because the universe only became a concrete story when the reader Suze evolved to read it. Before conscious observation, there was only a shimmering haze of undefined potential. It's a deeply romantic and empowering vision of the cosmos. It suggests that the line between physics and consciousness, between the outer world of stars and the inner world of our minds, is not as clear as we think. Do you believe consciousness is just a chemical process in the brain? Or could it truly be something woven into the fundamental fabric of reality? It's one of the biggest questions we can ask, and I would be fascinated to hear your perspective on it. Each of these ideas is a world in itself, a complete story of creation that challenges our sense of reality. From the elegant ballet of colliding brains in higher dimensions, to the infinite cosmic foam of the multiverse, to the staggering idea that we are living in a computer simulation, or that our own minds are co-creating the past. These are not just wild guesses. They are serious proposals born from the bleeding edge of physics and cosmology, attempts to answer the most profound question we can ask. The truth might be one of these ideas, or a combination of them we can't yet imagine, or something else entirely, something even more strange and wonderful. But the act of asking, of wondering, of telling these stories, is what propels us forward. We are storytellers, and the story of the universe is the greatest story of all. We seek its beginning, perhaps because in understanding its birth, we can better understand our own purpose. The journey to the time before time is a journey to the very heart of what it means to be, and to be aware. We've explored tales of bouncing universes, cosmic bubbles, and holographic realities. We've wondered if we are living in a dream, a simulation, or a story written by our own consciousness. But all of these tales hinge on one incredibly tricky character in our story: time itself. We think we know time. It's the clock on the wall. The rising and setting of the sun. The steady march from yesterday to tomorrow. But what if our everyday experience of time is just a stubborn illusion? A local habit that the universe doesn't share? Think about the arrow of time. Why does time seem to flow in only one direction? You can remember the past, but you can't remember the future. An egg can scramble, but you'll never see a scrambled egg unscramble itself back into a perfect whole egg. A glass can shatter on the floor, but the shards will never spontaneously leap back together to reform the glass. This one-way street of time is one of the deepest and most persistent mysteries in physics. Scientists give it a name: entropy. It's the idea that things in the universe tend to move from a state of order to a state of disorder. That perfectly built sandcastle of a child's afternoon, a state of low entropy, high order, will inevitably be worn down by wind and waves into a simple, disordered pile of sand. A state of high entropy, low order. The universe, as a whole, seems to be doing the same thing. This brings us to the most puzzling clue of all. The fact that time has a direction at all means the universe must have started in a very, very special state. It must have begun in a state of incredibly low entropy, of astonishing order. The Big Bang wasn't a chaotic, messy explosion like the name suggests. On a cosmic scale, it was a moment of unbelievable precision and perfect arrangement. It was like the universe, starting as a single, flawless crystal that has been slowly melting into a puddle ever since. It's like finding a clock that is perfectly and completely wound. The rest of cosmic history is just that clock winding down. But this raises the biggest question of all. Who or what wound the clock in the first place? Why did our universe begin in this one special, highly unlikely state? Out of all the infinite possible states it could have begun in, all the theories we've discussed, the Big Bounce, the multiverse, the colliding brainsare, in their own way, attempts to explain this fundamental mystery. They are attempts to explain where the wound-up state of our universe came from. A cyclic universe suggests the winding happens during the contraction phase, resetting the entropy for the next bounce. The multiverse suggests that while most universes might be messy, high-entropy messes, with so many bubbles being created, a few low-entropy ones like ours are bound to happen by chance, and we are here because only such universes can support life. But there's another, more radical idea, one that plays with the very logic of cause and effect. What if the universe's end determined its beginning? This is the mind-bending idea of retrocausality, where the future can influence the past. It sounds impossible, a violation of everything we know. But in the strange world of quantum physics, it's not entirely out of the question. Imagine our universe's timeline not as a river flowing from past to future, but as a complete story, already written from beginning to end. The requirement that the story must have a certain ending, for example. An ending that includes conscious observers like us could impose constraints on how the story is allowed to begin. The universe had to start in a low entropy state so that, billions of years later, galaxies, stars, and planets could form, and beings could evolve who were capable of looking back and wondering about it all. The future need for our existence could have been the cause that reached back through time and selected the specific, highly ordered initial conditions of the Big Bang. In this telling, we are not an accident of the cosmos. We are the reason it is the way it is. The end of the story wrote the first line. Now, let's take a step back from space and time altogether. Let's imagine a realm where they don't exist. What could possibly be there? Perhaps the answer is not a physical thing, but an abstract one. This is the idea that before our physical universe, there existed a timeless, spaceless realm of pure mathematics. Think of it as a kind of Platonic world, named after the ancient Greek philosopher Plato, who believed that a perfect, unchanging world of forms and ideas existed beyond our flawed physical reality. In this modern version, every possible mathematical structure, every equation, every geometric form, exists eternally in this abstract realm. Our universe, with all its elegant physical laws, gravity, quantum mechanics, electromagnetism, is just one of these mathematical structures. It happens to be a structure that is complex and rich enough to contain self-aware substructures, which are us. In this view, the universe didn't come from nothing. It emerged from this infinite library of all possible mathematical truths. The Big Bang, then, was the moment that our universe's specific mathematical structure woke up or came alive, transitioning from a purely abstract concept into a physically real entity. It's like a grand symphony that has always existed as a perfect piece of sheet music in the mind of a composer, and the Big Bang was the moment the orchestra began to play. The before wasn't a time or a place, but a state of pure, timeless, mathematical potential. The laws of physics weren't created in the Big Bang. They are the pre-existing blueprints from which our universe was built. This idea is beautiful because it suggests that the reason the universe is so beautifully described by mathematics is because, at its core, it is mathematics. We are living inside a mathematical equation that has become self-aware. This idea of creation from a non-physical source leads us to another elegant and powerful concept, the zero-energy universe. It sounds like a paradox, but it's based on some very solid physics. We think of the universe as being full of stuff, matter, and energy. And according to our laws, you can't create energy from nothing. So how did all the energy of the Big Bang appear? The answer might be that it didn't. The total energy of the universe might be, and may have always been, exactly zero. How can that be? It's because of a cosmic balancing act. Matter and radiation, like stars and light, have positive energy. But gravity, the force that pulls all this matter together, has negative energy. Think about it this way. To pull two objects apart against their gravitational attraction, you have to add energy. This means that the gravitational field itself can be thought of as a reservoir of negative energy. The stunning proposition is that the vast positive energy of all the matter in the universe is perfectly and exactly cancelled out by the vast negative energy of the gravity that holds it all together. It's like digging a hole. You end up with a pile of dirt. That's your positive energy, your matter. But you also have a hole. That's your negative energy, your gravity. If you put the dirt back in the hole, you're back to flat ground, back to zero. If the universe's net energy is zero, then it could have popped into existence from a state of literally nothing without violating the fundamental law of conservation of energy. It's the ultimate free lunch. The universe didn't need a creator or a pre-existing source of energy to get started. It could have been a random quantum fluctuation in a state of true emptiness, a nothing that borrowed positive and negative energy in perfect balance, creating a something that adds up to nothing. This makes the idea of our universe being born from a quantum fluctuation, a tiny random burp in the void, so much more compelling. It wasn't magic, it was accounting, and it beautifully complements the other ideas we've explored. What if the timeless mathematical realm contains an equation for a zero-energy universe? And what if the Big Bang was the moment this equation spontaneously solved itself, blossoming into a physical reality where positive matter and negative gravity perfectly balanced? What if the multiverse is an endless sea of these zero-energy bubbles popping into existence from the void? The idea that our entire, vast, glorious cosmos is ultimately just a fancy form of nothing is one of the most profound and strangely comforting thoughts in all of science. It means creation doesn't need a cause. It can be a spontaneous event, a natural consequence of the laws of physics and mathematics. Does the idea of a zero-energy universe, a grand cosmic balancing act, feel right to you? Or does it feel a little too neat, a little too convenient? Let me know what your intuition tells you in the comments. As we weave these stories together, a richer tapestry begins to form. We see how the mystery of the arrow of time connects to the initial state of the Big Bang. We see how the existence of a timeless mathematical world could be the source code for a simulated universe, or the library from which a zero-energy cosmos could emerge. We see how the need for our own conscious existence could reach back and shape the very beginning of the story. These ideas are not mutually exclusive. Perhaps the truth is a magnificent combination of them all. Perhaps we live in a holographic, zero-energy simulation that arose from a timeless mathematical reality, as one bubble in a multiverse whose initial conditions were fine-tuned by the requirement of our future consciousness. It's a mouthful, but the universe has no obligation to be simple for us. Our journey has taken us to the very edge of physics, philosophy, and imagination. We are grappling with concepts that strain the limits of our language and our intuition. And perhaps that is the final clue. Perhaps the reason the question, what was there before the Big Bang, is so hard to answer is that our minds, evolved on the plains of Africa to throw spears and find berries, are simply not equipped to comprehend a reality without time, without space, without cause and effect. We are trying to understand the ocean with the vocabulary of the desert, but we continue to try. We continue to build our telescopes, our particle accelerators, our theories, and our stories, because somewhere in this grand puzzle, somewhere in the answer to what came before everything, lies the answer to who we are and why we are here. The story is not over. The greatest revelations may still lie ahead. We've traveled through tales of infinite universes, colliding dimensions, and realities programmed like software. We've peered into the logic of a cosmos born from nothing and a past shaped by its future. But now we arrive at what might be the most profound barrier in our entire journey: the limits of our own minds. We are trying to understand the origin of everything, but we are doing so with brains that evolved for a very specific, very limited purpose. Our minds were shaped by the rhythms of day and night, by the need to find food and avoid predators on a single tiny planet. We are exquisitely adapted to think in terms of cause and effect, of beginnings and endings, of before and after. But what if these concepts, which are the very bedrock of our thoughts, are simply local bylaws that don't apply in the cosmic court? Imagine you are a creature that has lived its entire life in the crushing blackness of the deepest ocean trench. You have no concept of light, of sky, of sun, of air. Then, someone tries to describe a forest fire to you. They use words like bright, hot, burning, trees, smoke. To you, these words would be meaningless noise. You might try to translate them into your own experience. Perhaps bright is like a faint, bioluminescent glow, or hot is like the warmth of a hydrothermal vent, but you would never, ever grasp the true, terrifying, beautiful reality of a blazing forest. We might be those deep-sea creatures. When we ask, what came before the Big Bang? We are using a word, before, that is tied to the forward flow of time within our universe. It might be as meaningless as asking that deep-sea fish what a forest fire smells like. The very tools of our logic and language might be breaking down when we stretch them to this ultimate scale. This brings us back to one of the most debated and powerful ideas in this entire story. The anthropic principle. Are the laws of our universe the way they are for a reason, or did we just get lucky? Let's revisit this idea as two different bedtime stories. In the first story, we are the winners of a cosmic lottery of unimaginable scale. This is the weak anthropic principle. It aligns perfectly with the multiverse theory. Imagine that new bubble universes are being created constantly, and each time, a cosmic roulette wheel spins to determine the fundamental constants of physics for that universe. The strength of gravity, the charge of an electron, the expansion rate of space all are random. In almost every single bubble, the spin of the wheel results in a dud, a universe where gravity is too strong, and it collapses back on itself in an instant. A universe where it's too weak, and atoms never pull together to form stars. Lifeless, sterile, boring universes. And then, out of trillions upon trillions of attempts, one bubble happens to get the numbers just right. By pure, dumb luck, the constants are balanced on a knife's edge, creating a universe that is stable, long-lived, and complex enough for stars to form, planets to cool, and life to evolve. And of course, that's the universe we find ourselves in. We look around and say, wow, everything is so perfectly designed for us. But it's not designed. It's just that in all the other universes, there's no one around to be amazed. It's a form of selection bias. A classic analogy is that of a puddle of water waking up one morning and thinking, isn't it remarkable how this hole in the ground fits me so perfectly? The puddle doesn't realize that it only exists in that shape because of the hole it's in. In this story, we are that puddle, marveling at the cosmic hole that allows us to exist. It's a humbling view, casting us as a fortunate accident in an indifferent cosmos. But there is another story. In this telling, our existence is not an accident at all. It was written into the rules from the very beginning. This is the strong anthropic principle. It suggests that the universe, for some deep and unknown reason, must have had properties that would allow for the eventual emergence of conscious life. This isn't luck. It's a fundamental law of the cosmos, perhaps the most fundamental of all. This idea resonates deeply with the participatory universe concept we explored. The universe isn't just a stage for life. It's a system that requires an audience to become real. The laws of physics aren't just a random set of winning lottery numbers. They are the specific rules required to eventually generate beings who can look back and give the universe its meaning and its very reality. In this story, we are not just a lucky puddle. We are a crucial part of the landscape's design. The universe's journey from the Big Bang to us was not a random walk, but a purposeful unfolding, a destiny written into its fabric. It's a much more comforting and empowering view. It gives us a sense of cosmic significance. We are not just accidents. We are inevitable. Which of these two stories feels more true to you? Are we the unbelievably lucky winners of a cosmic game of chance? Or were we meant to be here all along? Share your thoughts on this profound choice in the comments below. There is no right or wrong answer, but what you believe says a lot about your own place in this grand cosmic story. So, where does our grand journey end? We've seen a dozen different paths, a dozen different stories of what came before the beginning. The Big Bounce, the multiverse, the simulation, the hologram, the mind of God in the form of mathematics. Is the answer one of these? Or is the truth, as it so often is, something that weaves all these threads together into a single, magnificent, and almost incomprehensibly complex tapestry? Let's try for a moment to imagine such a synthesis. Let's tell one final bedtime story that combines them all. Once, before time, there was only the silent, eternal, and perfect realm of mathematics, an infinite ocean of pure logic and potential forms. Within this ocean, one of the possibilities was the equation for a multiverse, a meta-law that allowed for the spontaneous creation of zero-energy universes. This law stipulated that these universes would be born from quantum fluctuations, little bits of something, created from a balanced nothing. And so, from the timeless mathematical void, an endless foam of bubble universes began to pop into existence. Our bubble was one of them. But the laws of our specific bubble had a unique feature, also defined in that initial mathematical blueprint. They operated on a holographic principle, meaning all the information for our vast 3D space was encoded on its 2D boundary. This made the universe incredibly efficient, perhaps allowing it to run as a simulation on some unimaginably vast cosmic computer existing within the larger multiverse. The program for our simulation was initiated. That was our Big Bang. And the parameters of this program, the fundamental constants of physics, were not random. They were carefully selected from all the mathematical possibilities based on the strong anthropic principle. They were the specific set of rules required to ensure that, eventually, conscious observers would evolve within the simulation. Why? Because, as the participatory universe theory suggests, the simulation could not become fully real, fully concrete, until it was observed from within. Our consciousness is the read function that collapses the quantum code of the simulation into the tangible reality we experience. We are the universe's way of running its own program, and perhaps this entire process is cyclical. Perhaps when our simulated universe reaches its end, it doesn't just shut down. Perhaps it triggers a reboot, a big bounce, where the information on the holographic boundary is reset, leading to a new collision of brains in a higher simulated dimension, starting the cycle all over again, refined and informed by the previous iteration. In this grand, all-encompassing story, everyone is right. The universe is a bounce, and a bubble, and a hologram, and a simulation, all born from a timeless mathematical truth, and all made real by our own minds. It's a breathtaking, dizzying thought, a cosmic nesting doll of mysteries. It suggests a reality so much deeper, so much more interconnected and bizarre than we could have ever imagined. And so, we finally come back from the edge of reality, back from the time before time, and return to here and now, to you, sitting there, watching this. We end where we began, by looking up at the night sky. The next time you see the stars, remember these stories. Remember that you are looking at the embers of a cosmic fire that began 13.8 billion years ago. Remember that you are made of stardust, atoms forged in the hearts of dying stars that were born from the remnants of that initial fire. Remember that the light entering your eyes from the most distant galaxy began its journey long before humans ever walked the Earth. And remember that the question you are asking, where did all this come from, is the universe asking itself that very same question through you. The search for what came before the Big Bang is more than a scientific puzzle. It is the ultimate expression of our human desire to find our place in the cosmos. It's the grandest origin story, the search for the first page of the book of reality. We may never have a final, definitive answer. The ultimate truth may be forever beyond the grasp of our deep-sea minds, but that doesn't matter. The journey itself is what changes us. The act of wondering, of imagining these incredible possibilities, expands our minds and our souls. It connects us to the vastness of the cosmos, and to the deepest parts of our own consciousness. It is the greatest bedtime story ever told, because it's a story that we are all a part of, and it's a story that may have no beginning and no end, just an eternal, wondrous, and ever-unfolding mystery. Our cosmic bedtime story is now drawing to a close, but the universe's story, of course, never truly ends. We have traveled to the very edge of imagination. We have danced with ideas that bend our sense of reality, and we have stared into the deep, dark well of the time before time. We've heard tales of a universe born from nothing, a universe that is one of an infinite number, a universe that bounces through eternity, and a universe that might just be a dream in a cosmic mind, made real by our own awareness. We leave this journey not with a simple answer in our hands, but with something far more precious, a profound and beautiful sense of wonder. The goal was never to solve the ultimate mystery, because some mysteries may not be meant for solving. They are meant to be experienced. They are meant to stretch our minds and open our hearts to the sheer, incomprehensible scale and strangeness of existence. The fact that we can even ask these questions, that a collection of stardust like a human being can contemplate the origin of the entire cosmos, is the greatest miracle of all. It is the universe becoming aware of its own magic. So, as you go back to your day, or as you drift off to sleep tonight, carry a piece of this wonder with you. Remember that you are not just living in the universe, you are the universe experiencing itself. Your thoughts, your curiosity, your very consciousness are woven from the same fabric as the most distant stars and the deepest mysteries of time. The same creative energy that sparked the Big Bang is alive within you right now. I have one final question for you. After traveling through all these incredible, mind-bending stories, which one has stayed with you? Which idea whispers to you in the quiet moments? Was it the comforting rhythm of a bouncing universe? The infinite possibilities of the multiverse? The startling logic of the simulation? Or the profound connection of a participatory cosmos? Let me know in the comments below. There is no right answer, only your own personal resonance with the grand story. I truly would love to read about the journey your mind went on. Thank you for joining me on this incredible exploration. If this journey has sparked a fire of curiosity in you, and you enjoyed traveling to the edges of what we know, please show your support by liking this video. And to make sure you don't miss our next voyage into the beautiful unknown, consider subscribing to the channel and ringing that little notification bell, so you'll be the first to know when our next story begins. For now, look up at the sky whenever you can. Listen to the quiet whispers of the cosmos, and never, ever stop wondering. Sleep well, and dream of the endless possibilities that lie hidden in the heart of reality.